ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಹಾಂ ಹಾಂ, ಕೊಡಿ ಕೊಡಿ. ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಹಲೋ.
ಇಲ್ಲ, ಮೈಕ್ ಹಿಡೀರಿ, ಆಡಿಯೋ ಕನೆಕ್ಟ್ ಮಾಡಿ ಏನಾದ್ರು ನಾಳೆ ಅಂದ್ರೆ
ಸೋಪ್ ಹಾಕೊಳ್ಳು, ಮೈ ಉಜ್ಕೊಳ್ಳು, ಬಾಗ್ಲಾಕೊಂಡು ಸ್ನಾನಾನೇ ಮಾಡ್ಕೊಳ್ಳು, ತಲೆ ಬಚ್ಕೊಳ್ಳು, ಪೌಡ್ರ್ ಹಾಕೊಳ್ಳು, ಬರ್ದಿದ್ರು
ಯೂಟ್ಯೂಬಲ್ಲ? ಸರಿ, ಒಂದು ನಿಮಿಷ ರೀ. ಮೈಕ್ ಬರುತ್ತೆ. ಹಾಂ, ಅವ್ರದ್ದು ಮೈಕ್ ಬರ್ತಾ ಇದೆ, ಆಡಿಯೋದು ಬರುತ್ತೇನೋ ಗೊತ್ತಿಲ್ಲ.
Associate Professor at the Department of Data Science and Artificial Intelligence, and also Associate Faculty at the Department of Computer Science and Engineering at IIITV. Sir is a Fellow of Institute of Engineering, India, Senior Member, Institute of Electrical and Electronics Engineers, New York, USA, and also Senior Member, Association for Computing Machinery, USA, and is the former Infosys Foundation Career Development Chair Professor. Sir is the convener of Spatial Computing Laboratory at IIITV. Dr. Uttam sir holds a Bachelor of Engineering degree in Computer Science and Engineering from Visvesvaraya Technological University, Belgaum, and also Diploma in Advanced Computing from CDAC, Pune, Master of Science degree in Geoinformation Science from University of Twente, the Netherlands, and PhD in Algorithms for Geospatial Data Analysis from Indian Institute of Science, Bangalore, and he earned professional certifications in data science, computational data analytics, and machine learning from MIT, USA, and also in big data from Stanford University, and in spatial computing and geospatial intelligence from Pennsylvania State University, USA. Sir worked as a project assistant and as a research associate at IISc Bangalore, and was visiting scientist at GISE Lab, Department of Computer Science and Engineering, IIT Bombay, and prestigious Indian Institute of Management, IIM, Indore. He has appointed as faculty member in the information systems area. He moved to NASA, IIM's Research Center, Field, Mountain View, California, and also NASA postdoctoral fellow, and successfully served as a visiting scientist at NASA, US area for almost 4 years, and subsequently he secured an appointment to a researcher position in the Department of Biomedical Data Science, School of Medicine at Stanford University. He has published more than 35 research papers in national and also international journals of repute, 25 book chapters, and 106 papers in conference proceedings, and 8 technical reports. He has delivered more than 150 invited guest lectures by different institutions and organizations in India and also in abroad. He has received several awards, including Karnataka Science and Technology Academy Innovation Discovery Award by 2025, and also Indian National Geospatial Award during 2021, Sayadri Shikshak Award in 2020, IISc Bangalore, the Institute of Engineers India Young Engineers Award, NASA Group Achievement Award by NASA, Washington DC, and Veblen's Sphere Review Award during 2017, and Certified Sentinel of Science Award during 2016 in the Earth and Planetary Sciences. With this brief introduction, so we are very happy, sir, for your acceptance. And sir left NASA and Stanford. He came to IIT to serve in India. So we are very much thankful for accepting our invitation. So any training programs, we always come to mind. Uttam sir is there. So like that. So it is the one brother for KST also. Thank you, sir, and RT welcome you for taking this session, sir. Please.
Thank you. Good morning, all of you, and thank you, Srinivas, for the elaborate introduction. Good morning, Dr. Honegowda. So I have been associated with this academy for a very long time, and possibly Dr. Honegowda, sitting right here in front, invited me for a guest lecture long back in 2008 or 9, somewhere close to that, when KST had a different office, and I was in touch with Srinivas, and he used to often invite me after sir retired, and great to see you back, sir, for the this program. So we will go ahead, and we have 2 sessions current for me, where I will be talking about clustering and PCA, and detection and ensemble methods. So it is not actually possible to cover all 4 topics in detail in 2 hours or so. So I will try to touch upon few important aspects of these topics, and my student who will be arriving after lunch, she will continue from ensemble methods and slowly dive into hyperparameter tuning, and then she will talk about CNN and RNN deep learning techniques. So I will first build the foundation so that you have a easy transition from these topics to deep learning ideas. Okay. I have one notes which I will share with you later on. So this is a handwritten notes, and it contains the detailed derivation of PCA. So I have scanned it and I will share it. So this notes is from my class where I learned PCA first time in IISc. So this was a part of one course called multivariate statistical data analysis, where we were taught PCA. So that note still is very good, and I have retained it in good shape along with a scanned version, which I will pass it on to you. I also have another printout on a tutorial on principal component analysis. I can share this also, so you can refer both. After the presentation is over, I will pass it on to Srinivas and he will further give it to you. Because it's not possible to complete all the topics in the 2-hour session. So we will give you a brief introduction and keep later details as part of the online e-version copies that I have. I will share that. Alright, so let's get started with this session, where we will first talk about the topic on clustering. So before we enter into the world of clustering, we will quickly see some important ideas that started or that is the genesis behind supervised and unsupervised learning. And this will give us a small background to see why is clustering required and why we should learn that. So since this workshop is on data science and machine learning, so I would like to reiterate that data science actually is a end-to-end procedure, end-to-end method, which talks about data collection. Data collection can happen from different sources, for example, online questionnaire, or collecting data from some organization, or surveying surveying and getting the data. And therefore, because data are collected by different people at different times, they have variations in units, they have variations in scales, they have variations in times, because all data are not collected at the same time. And then they also have variations in granularity. Granularity means to what details you have collected the data. So as such, when we work in data science, we need to bring a coherence among all these variations. Before we perform any data integration for any particular data modeling aspect, we need to first take care of these variations present within the data. So when we talk about data collection from different sources, the next step obviously is about data cleaning. Data cleaning encapsulates how do we remove some erroneous value or some outliers from the data and make it clean, which is ready for any data analysis. After data cleaning, we go ahead with data merging or data integration. So data merging, data integration is required because your data might have come from different sources at different points in time. So we might need to scale the data, normalize the data to some common platform, and then we try to merge them or integrate them so that we we have a single repository of the entire data set, maybe in a Microsoft Excel file or a CSV file or notepad and so on. So all these steps such as data collection, data cleaning, data standardization or normalization, data integration, they are all related to making your data analysis ready. So till this point, you might have spent months from data collection to data cleaning and data organization, but your actual data analysis has not yet started. What you have done altogether is made your data analysis ready, made your data analysis ready. Now comes the actual part where we need to analyze the data, and hence the word mining comes. So when we say data mining, we are actually trying to see if we can mine something, analyze something, and extract some useful information from the data. So the word data mining is now almost 20 years old. I studied this subject in 2006 when I was doing my PhD. There is a very nice book by Hanan Camber on principles of data mining. So as per that book, data mining is defined as follows. So it says data mining is a collection of methods or systems or processes or algorithms which are used to extract hidden, non-trivial, useful information from the data. Hidden, non-trivial, useful information from the data. So our focus today using either supervised or unsupervised method is to see how to perform mining. What do we get from mining? Mining, specifically mining related to data mining. Once your mining is complete and you have been successfully able to extract the pattern, we then go ahead and try to evaluate the pattern. How good are the patterns? How reliable are the patterns? Can you use these patterns for any decision making? Okay, and then once you are convinced that my patterns are really useful, we can further present them in the form of knowledge. So maybe writing a report or a PowerPoint presentation or putting the results on some web platform will help you to disseminate the knowledge. So we see that data science is actually a collection of scientific methods or processes or algorithms or systems. All these are similar words, and the idea is to extract knowledge or insights from the data. These data can be sometimes structured, very nicely arranged, curated, or sometimes unstructured. You may have to do or perform some data pre-processing to bring it to a nice formatted shape. Okay. Very often in data mining, we see that the term big data is closely associated. So the term big data has emerged in the last 1 decade with three characteristics defined by 3 V's. The 3 V's are volume, velocity, veracity. V. Volume, the big data, the term big data is characterized by 3 V's: volume, velocity, veracity. Okay, so we will not get into big data terminology and their concepts here, but the idea is that because of the big data emergence from various sources such as satellites, Earth observation satellites, or maybe thinking about telescopes scanning the skies, the data generated from telescopes scanning the skies, or data generated through some gene expressions, or data generated through some scientific experiments, scientific simulations, all are sources of data that typically generate huge volumes of data. Volumes in the sense maybe terabytes or even more. As per some recent estimates, the current global climatic data is of the order of 30 petabytes. Current global climatic data is of the order of 30 petabytes. So you see that data coming from different sources actually build upon and slowly lead to big data. Therefore, big data technology has now emerged as one of the focal areas in data science where people are trying to work on and see how to analyze and get insights from big data. Okay. Now, very interestingly, we see that the word data analysis is not new. Data analysis has been there for almost 50 years. Some of the original books were published long back in 1960s and 70s on multivariate statistical data analysis. So that is where ISI Bangalore, ISI Kolkata and all work on data, and the word data analysis using different techniques has been there for a very long time. So the very important question is, then what are we learning today? If data analysis is 50 years old, statisticians have been working on data analysis techniques for so long, then why suddenly data science has become so important? The reason is, most of the traditional data analysis techniques were developed based on certain assumptions. For example, assumptions of sample size, assumptions of distributions and so on. Now all these big data coming from satellites, gene expressions, scientific experiments, they do not meet these assumptions because of the large volume. They do not even fit the distribution. Hence, you cannot directly apply these statistical techniques, rigorous statistical techniques on this big data. You cannot right away apply these old statistical techniques on the big data. Agreed that these old statistical techniques are very stable, proved, but we cannot merely apply because those assumptions are not met. Here comes our savior. So machine learning or data science typically helps us in narrowing down the data size. So when you apply machine learning, you tend to classify the data, tend to cluster the data, tend to segment the data. Okay. These classified output or clustered output or segmented output are much smaller compared to the big data. Hence, on these classes, clusters or segment, you can now apply these statistical techniques and prove or disprove the hypothesis. Okay. So the mere role of machine learning is to extract only some useful hidden pattern which can be validated using the traditional statistical technique. So we see that in all the different problems in and around our Earth related to satellites or related to some genes, the challenge is very straightforward. The challenge is to see the big data and make sense of that data. Make sense of the data. So when we say the word make sense of the data, we actually mean we would like to extract important patterns from the data. We would like to extract important trends from the data. And our goal is to understand what the data says. What the data says. This is what we call learning from data. This is what we call learning from data. Okay. If you look at the overall picture of AI and machine learning, see that it has many topics to learn. Okay. And maybe yesterday you had some good introduction, and today we are here in part 2. It is not possible to cover all the topics in a 3-day workshop, but to give you some broader perspective of what all these techniques contain, we see that today we are here. Today we are here, clustering methods. The last bullet of the second point, machine learning foundations. Okay, so there are many more topics that you can explore and we will try to learn. Neural network, for example, is another interesting topic that will be introduced today when my student will come at 3 o'clock and talk about neural network. Computer vision will be covered partly tomorrow by one of my colleague, Professor Raghuram. And then you have another set of topics related to optimization and hyperparameter tuning, which Shruti, my student, will cover after the lunch break. And then we have some other related topics like security in machine learning, security in privacy in machine learning, applications in healthcare, ethics and responsibility, and so on. So we see that currently we are here in this overall pipeline. If you try to visualize this entire picture, in the form of steps, in the form of layers. Okay, thinking that AI is the top layer. The word, very common word AI that we keep using every day, is the top layer. See that our workshop is trying to focus here on machine learning techniques and partly into these topics. Okay, so the terms clustering, that is our discussion, clustering, PCA, okay, and ensemble methods are the first three topics that we would like to cover today. And beyond this, Shruti, who will be joining after the lunch, will talk about some deep neural networks and deep learning techniques. Okay, and tomorrow we have sessions on generative AI and agentic AI. So you will be able to get overview of most of the top topics at a superficial level, but it's always a good idea to get into depth later on. Fine. Okay, just to get some idea, how many in the audience are not aware of AI principles, algorithms, and are first time attending a workshop on this in this broader agenda? Some, and others, have you used AI or some algorithms earlier in any task? Okay, so I will not skip anything for the benefit of everyone. Let me touch every part that is important. Okay, let's begin with some very simple examples that we see in day-to-day life. Okay, think of a AI software that has been developed for recording medical or parsing medical records. Okay, the medical records typically belong to patients, and the idea is to see what was the kind of disease the patient had and what was the treatment or medication given. Okay, so let the machine learn this disease, treatment. Okay, in future, can I use that software, AI software, to find out a proper medication for a new disease? For example, COVID. So there was no medicine for COVID before COVID, and as soon as the disease emerged, then can we use our previous 100 years experience and try to see if old disease can be mapped to similar to COVID, and can we come up with a medicine? Okay, so now we add the aspect of AI, and can we say, is it possible to, or can we use AI to predict a possible treatment for a new disease? Okay, let's look at the second example, smart homes, smart offices. So why are homes smart? Homes are smart or offices are smart because they have been trained to optimize energy cost. So when we say energy, typically it can be electricity or it can be water. So we are trying to save on natural resources. So we have smart washing machines, smart air conditioners, smart lighting system. So as soon as all of us leave the room, all lights get switched off, and as soon as we enter, all lights get switched on, right? So we are using sensors, IoT devices, and so on to see if there is a requirement to utilize that energy, water or electricity, and all these equipments have been trained when to switch on, when to switch off. Therefore, they make our houses or offices smart. Smart houses, smart homes, smart offices. Okay, let's look at the third example. Third example talks about personal software assistants. For example, Alexa or Siri or any other Google Assistant and so on. So why are these personal assistants so useful today when it was not there 2 years back, 3 years back? Merely because they help us in some day-to-day activity. So we would like to know the news, today's weather outside, today's traffic situation. So the way we interact with these devices slowly learn and they know what we want. So typically few of us might want to use Alexa to listen songs every day. So they know what kind of songs we keep listening to, and because they are trained over and over time, day after day, they are trained. So once they are trained, they know what is our likings, what is our choices, and hence they help us in making some right decisions or making our life easier by giving us ready-made information. Okay, so in the three examples that I have just now quoted, see the word learning appears. in all the three examples, our goal, our concern is not to analyze the meaning of English word learning. Although learning appears in all the three bullets, our goal is not to understand the meaning of English word learning. Instead, our goal is to understand or define a class of problems that encompass interesting forms of learning. So, AI software or smart homes or personal software assistant are a class of problems which encompass interesting forms of learning. So, our goal here is to explore different methods, different algorithms which help us in trying to solve these three types of problem or many more such types of problem. Our goal is to understand the problem, understand their structure, and understand the processes behind these. See, we can only make the home smart once we know how the homes work, what are the requirements. So we need an air conditioner, we need lighting systems, we need smart washing machines and so on, smart dishwashers and so on. So because our requirements are known, we know the structure, we know the process, hence we can develop a AI-based solution to that. So AI or machine learning helps us to understand this structure or the processes behind these methods. Okay, let's go through some more similar examples. Think of a AI ML based software developed for a patient. Okay, the software typically parses different clinical data of the patient. Okay, so the software also parses diet plan for the patient, and software also goes through the demographic data. Let's say the patient had a heart attack. Now based on the clinical output measurement, based on the demography, based on the diet, can your software predict whether the patient might have a second heart attack if the same lifestyle continues? Second example, can we develop a AI based software which can predict the price of a stock in 6 months from now? So what will be the data required for this kind of prediction? Maybe company's performance or maybe any economic data will be the input to this model, and the model might be able to predict price of a stock in 6 months from now. Third example, let's say we have a postal system, and in the postal system, can I use AI to read the PIN code, zip code written on the envelope, and based on the zip code, can my software reroute the envelope to the appropriate destination? So this will typically solve manual sorting, right? And things will become automated. So what is the advantage? Advantage is that your postal system will become more efficient, delivering the envelopes before time or on time. Fourth example, can we think of a AI-based software which is capable of estimating the amount of glucose in the blood of a diabetic patient? Okay, maybe using some technology, for example, using infrared absorption for a spectrum of that person's blood or so on. Okay, look at the words. The words that I am highlighting are predict, identify, estimate. These four words are important because they tell us in what kind of scenario AI can be used, or what is the type of algorithm that is to be used in such scenarios. Okay, so we can make out that two of the problems are prediction problem. So prediction problem means there is some kind of a technique or a set of technique that has been designed for prediction can be utilized here. The third one is identification, recognition. Okay, so for example, object recognition. So you might have seen in CCTV cameras, they have night vision. If somebody is trying to enter inside the house, the camera will detect it, right? So what it is doing? It is detecting, identifying, recognizing an object, right? So even autonomous vehicle have this kind of a software system. So identify is a keyword that will tell you that this type of AI algorithm can be used here. Or the last one, estimate. Estimation is a keyword which is an indication that these kind of problems can be solved using algorithms that help us to estimate something. We are not narrowing down right now, estimate something. Okay. Now, to bring these 4 words into context or to relate them to machine learning data science, we will see 2 important terms here. One is classification, other is prediction. If you pick up any machine learning book, most the basic books, most of the chapters will be dedicated to classification algorithms and prediction algorithms. Apart from that, there will be few chapters on, for example, the foundational materials, matrix algebra, calculus and so on, but apart probability, statistics and so on. But most of the book chapters will be dedicated to these 2 terms, classification and prediction. Let's talk about the first word, classification. Okay. Classification means the algorithm is trying to assign a class label to every data point. Example, let's say we have approximately 50 people in the class, okay, and I have a Microsoft Excel file, okay, and I have a record of 50 people. So what is the record? So record, let's say, for example, assume that after every session we have a 10 minutes test related to the session. You write the test. The test has some questions just to see your understanding of that subject. Okay. So for each session A, B, C, D, E, I will record your marks. Okay. And tomorrow after the last presentation, you will be given a certificate saying that this student has scored this marks in all the subjects, so has successfully completed the training program with A grade. Okay. So I need to then assign grades to you. So what grade? Maybe A minus, B plus, B minus. 5 grades. So I have your marks ready for after every session, 95, 92, 91, 89, 91, for example. And finally, I need to provide a grade to you, the last column, grade to you. So this grade is called class label. I am assigning a label to you. He got A, she got A minus. So A minus, B plus, B minus are labels. These are grades, I agree, these are grades, but these are labels being assigned to every individual participant to be printed in the certificate. Okay. For a small class of 50, it is fine. We can sit for 1 hour, evaluate all the answer scripts and give the grades. Okay. But if, let's say, there are 1 million participants, example IIT JEE entrance, NEET exam, manually if we keep doing, it will take 6 months to release the result, right? So can we automate this correction? Okay. So let's say I have 100 students record or 50 students record for marks in A, B, C, D, E session, and based on that I give the grades. Okay. So now what I will do, I will tell a machine learning algorithm, hey, look at this table, learn it. So the machine learning algorithm will learn, okay, first student got 95, 92, 91, 99, 91 in 5 sessions. So the evaluator has given grade A. It will learn for all 50 participants. Okay. This data is used to train the algorithm. Hence it is also known as training data. Once your training is complete, okay, I can use this trained algorithm or a model. A trained algorithm is also called a model, to now assign grades to 1 million students, and this will happen in 1 or a fraction of second. So I have trained my model saying that, look, if these are the kind of marks, please give A. If these are the kind of marks, please give A minus. And the machine has learned. So now I can use this automated system to give grades to 1 million students. This is called classification. So what I am doing, I am trying to assign a class label, class A minus, B plus, B minus to every student. Therefore the word classification. This data is used to train the model, hence it is also called a training data. Okay. The second important word in this slide is prediction. Prediction algorithms are used to model continuous valued function. So they are typically used in predicting unknown value or missing value. For example, linear regression. Linear regression, those who have studied may know that is very well used to model the data pattern and can be used to find out unknown value, missing value from the range of data. Okay, so we see that generally classification and prediction are two important topics in data science or machine learning. Within classification, there are two types, supervised and unsupervised. Okay, look at this word, supervised. Supervised means under the learning, under the supervision of something. What is that something? That something is this data called training data. So here in supervised learning algorithm, the training data, for example, your marks in every session, which are known as observations or measurements, accompanied by labels. What labels? These labels, A, A minus, B plus, B, B minus. Okay, so here the training data is used to train the algorithm. The training data which has marks of all 50 of you in 5 different sessions, along with the grades which I have computed manually. Okay, I will use this data as a training data to make the algorithm learn. Therefore, you see that the learning is happening under the supervision. Under the supervision of what? Under the supervision of this training data. Therefore, they are known as supervised learning. Therefore, they are known as supervised learning. Now, once my model is ready, apply this to IIT JEE entrance. Let there be 1.3 million students. No problem. I will any new data, JEE exam, IIT JEE exam, NEET exam, any new data, just run your model. Within 1 to 2 seconds, grades are ready for all 1 million students. Now, why I am so confident about this? Because I have trained the model under my supervision. I have generated this data myself. I corrected everyone's copy one by one every day and calculated the total marks. Based on the marks, I gave these grades manually. So I am confident that this grading is perfect. Now I am telling the machine, look at this grading system, learn it. I am very confident that this training data is correct because I have done it myself. I am saying that, okay, learn it. Once you have learned under the supervision of my training data, now you are ready to give a class label or grade to any new data. So this technique therefore is called supervised learning because it has been trained under the supervision of a data called training data. Okay. Look at the second term, unsupervised. Let's say I have your marks here in 5 different sessions, A, B, C, D, E. Okay, for 50 of you, 1, 2, 3, 50. Okay. I don't know anything about the grading system. Nobody told me here that you should provide grade to every student. Just everyone said that compute the marks, keep it in the Excel sheet. Okay. So now the question is, if grading is not provided, grading means A, A minus, B plus, B, B minus, then what should I do with the data? It's just a tabular column in a Microsoft Excel file, right? It does not make much sense to me because there is no grading provided, just some tabular data. Now, can I group each student based on the marks? So I will say, okay, let's do one thing. Let's create one group of students where everyone has scored more than 90. So group number 1. Group number 1. Okay. Then I will say, okay, let's create another group where every student has been able to score between 80 and 90. Okay. And group number 3. So I have now group number 3 where I will write here. Every student has scored between 70 and 80. Okay. I have no grading scheme, but I have just manually grouped, okay, these people are the toppers in the class, more than 90. These are the second best students from 80 to 90 and then 70 to 80. So what did I do? I have created 3 groups, 1, 2 and 3. But I don't know what label to give. There is no label provided. So I will just say that these students did very well, excellent. These students have done just next to that, very good, and then third one, satisfactory. So see that there is no label provided. I have given my own labeling, excellent, very good, and satisfactory. Right. So what did I do? I just grouped all of you. So this grouping is done by me based on your marks, but there is no label, no grading. Right. So this is known as unsupervised learning because there is no supervision. On my own, I decided, okay, let's put everyone who got more than 90 into blue group. Let's put everyone between 80 to 90 into orange group. Less than that into green group. You can define your own criteria. Saying that no, I don't agree with your marking scheme, so I will do something else. So I will say people more than 95 should be in the blue group, and 85 to 95 should be in the orange group. So you can define your own criteria. So see that here there is no training method, but each one of us can come up with our own style of grouping people. This is known as unsupervised learning. There is no supervision. Therefore, the term unsupervised. So as a data scientist, we need to figure out what is 1, what is 2, what is 3. So this 1, 2, 3 interpretation can change for me, can change for you. I said 90 to 100, 80 to 90, 70 to 80. He said no, let's keep it 95 to 100, 85 to 95, 75 to 85. That's fine. There is no rule given, so each one of us are interpreting in our own way. But interpretation is done based on our convincing level. This is known as unsupervised learning because there is no supervision. Each one of us are trying to understand the data based on some grouping. Okay, let's see one example. Autonomous car. All of us have heard and seen several videos related to autonomous car, right? So how did the car become autonomous? Initially, there was a driver in the car who used to drive the car from morning 8 to evening 8, 12 hours, okay, on all types of roads, highways at different speed limits, trying to follow all road rules, slowing down when a pedestrian is crossing the road, moving on green signal, and so on. There is a sensor on the top which keeps taking pictures and collecting information about the neighborhood. So the algorithm slowly understood what is the kind of action the driver takes when there is a certain kind of surrounding. So if the surrounding says people are crossing the road, the driver slows down. So algorithm understood this. When the driver picks up from 0 velocity to higher, the algorithm understood that there is a green signal, and so on. So it learned, and once it learned, it became almost close to perfect. It made mistakes, yes, agreed it made mistakes, but it learned from its mistakes also. So over 10, 12 years of training, every day, every night, this car has now become perfect. And it can replace humans because it doesn't make mistakes, it doesn't get tired. So for long journeys, this self-driving car is excellent. Some states in US already have given license to this car. So you get down at airport, take the self-driving car. It will drop you at your home or hotel. This is an example of a supervised learning. The car has learned under the supervision of a driver, expert driver. Okay, and once it has learned, now it is ready to go without a driver. Trained model, trained car. This is an example of a supervised learning. Look at this picture. This picture shows 1.1 billion Facebook users around the globe. Okay, so now if I give you 1.1 billion data points and say that generate this graph, it's very difficult because your screen may not be able to highlight those many pixels at one time, right? Now this map is very, very important because Facebook wants to know the density of people using Facebook. Why? Because you know the reasons. It will use that data to for advertisements, to generate revenues, right? So you can see that certain regions, for example, eastern part of USA, eastern part of South America, Europe, England, India, Southeast Asia, then parts of Australia, New Zealand, and Japan. The users are really high. Other parts, users are low. Fortunately, India has the highest number of Facebook users. This is the old data generated by Facebook in 2020, followed by United States and so on. So question is, how was this map generated? This map has been generated from your own data and you may not know. So when you register in Facebook, you provide your details, name, gender, city, pin code, something like that. This map has used your geolocation in the form of x, y, latitude, longitude, okay, and grouped everyone based on the location. They have used an algorithm called DB-scan. DB-scan, density-based scanning technique. So what it does, for every unit area, it computes the number of users and gives the density, not the numbers, density. So the more brighter patches represent more people. More brighter patches means density is high, means more people are there, more Facebook users are there. Okay, and this map now is very, very useful for revenue generation. So more people, okay, advertise more. At least even if one person clicks on that buy now any product, sales will increase. This is an example of unsupervised learning. No training provided, just gave the Facebook data, told that give me a world map showing the number of users. Done, got it. From your own data, which you may not know, from your pin code or city, latitude, longitude. So example of unsupervised learning. Okay, so what we have seen is that supervised learning typically might be of classification or prediction. Okay, in classification we have a categorical label, A minus, B plus, B minus, grading, or continuous label for prediction. Okay, in unsupervised learning, which is also known as clustering, there is no label. Each one of us will come up with our own label because it's group, it's just grouping, there is no label. So the meaning of the groups has to be done by our own. We have to interpret, as a data scientist we have to interpret what is these groups. Okay, so having this small introduction to unsupervised learning, we will now get into clustering, which is our topic today. We already have some idea that clustering means grouping something without any prior knowledge, without any labels, unsupervised method of grouping something. Okay. So we will try to cover few important topics, not all. Wherever there is something that you can read on your own, I will skip that part, but I will tell you that this you can read. But other important things I will quickly highlight. Okay, so unsupervised method is also known as clustering. Okay, what is the clustering? A clustering means grouping of some objects, a collection of some data points. Okay, so these groupings, for example, group 1, group 2, group 3, and so on, will be dissimilar to each other. Means group 1 will not be similar to group 2, they will be dissimilar. Group 2 will be dissimilar from group 3. So group 1 will be dissimilar from group 2 and group 3, and so on. But within each group, the data points will be similar. So every data point within group 1 will be similar, but every data point within group 2 will be similar. But see that group 1 and group 2 are not similar, they are different. Therefore, they are two different groups. For example, let's say we will use RGB colors, 3 colors, and group all of you. So it's possible that sir is wearing a white shirt, he doesn't belong to any group, right? But I will tentatively put him in some group, saying that sir, we have only 3 groups, please accommodate, right? So if we do that, as per my understanding, I will pick up everyone's shirt or color and put you in RGB, 3 groups, red, blue, green, right? So this is one type of a grouping. Now everyone in the R group will, I assume that will be wearing red or similar clothes. Everybody in green group will be wearing green or variations of green clothes, right? So red is completely different from green. So group 1 is completely different from group 2. but people within group 1, within green or red or yellow will be similar. Correct? Okay. So we see that clustering analysis is used to find similarities between data points. So I want to see how many of you are similar. Tell me one more criteria based on which I can group all of you. One more criteria. Age. So I will say, okay, 20 to 30, one group. Sir, don't feel bad. Senior citizen, with all due respect. 30 to 40, another group. 40 to 50, all group. Senior citizens, one group. So my own way of trying to put people in groups. Okay. So clustering is used to, okay, even though sir is senior citizen, he is still active and he is the professor in KSR-SAC, still teaching. So very active person. So idea is to find similarities between data points and put them in some group. Okay. This is a kind of unsupervised learning, no predefined classes. There is no class. Just by my own experience, I am just putting all of you based on color of your t-shirt, based on your age, based on gender and so on. Okay. What are the typical applications? It is a very good standalone tool to get inside about the data. I will come to know, okay, what groupings are possible, what distributions might be possible, and it is also used as a pre-processing step for many algorithms. We will see this later. Let's take one example. So I have different types of news, okay, in your mobile phone or in newspaper. How do I group them? So I will look at the keywords. I will look at the keywords and maybe try to group them based on the keywords into 3 categories: entertainment, politics, sports. This is my understanding. Your understanding can be different. You will say, no, sports is a very broad term. Please clearly say cricket, lawn tennis and so on. So that's fine. It's your clustering idea. This is my clustering idea. So these are 3 clusters. You can come up with your own. You can add, put market as one of the, Sensex as another class, because I do trading every day. So fine, that could be the 4th cluster. So clustering is the process of discovering groups or clusters in a large database, like we saw in the newspaper example. We don't need any a priori information. We don't need any a priori information on the number of groups, okay, or the labels. I said we can come up with 2 groups or 3 groups or 4 groups. Gender, 2 groups. Color of t-shirt, 3 colors. But we can say, no, let's add white as one more color, black as one more color. So 5 colors. There is no predefined number. I can change. Also, there are no labels. So based on my priority, my understanding, I can change the labels. Therefore, it is called unsupervised learning. There is no supervision. I keep changing number of groups. I keep changing the number of groups and also the criteria for grouping. So therefore, it is called unsupervised classification. Okay. So you see that the entire thinking process behind clustering is based on similarity criteria. Same color, same gender, same age group, similarity. So let's group them together. Similarity criteria is something that is a keyword in clustering. Okay. Additionally, type of data, whether it's numeric data, integer data, or ordinal data also is important. For example, gender, male, female, is a binary data, right? Whereas age is an integer data. So can I use the same algorithm for both? May not be possible. Okay. Okay. So clustering actually reduces to determining high density groups of point, group 1, group 2, group 3 from a set of non-uniformly distributed point. So all of currently it's a non-uniformly distributed point. What I will try to do is group all of you into high density group, blue group, red group, green group, male, female, age and so on. Okay. There are many application areas. Some bullets I am skipping because I have already explained them while talking. Example, socioeconomic and demographic data can be clustered on the basis of several things. Rate of unemployment could be one factor, population could be another factor, per capita income could be 3rd factor, life expectancy could be 4th factor. So these are criterias based on which I can group the entire population. How many people are employed in the country? Not employed. What is the per capita income of every group? Okay. So areas or regions that have similar values for any one of these attributes, rate of employment, population, per capita income, lifestyle expectancy, will be grouped together. This is the genesis or idea behind clustering. Okay. So what are the important requirements for clustering? Okay, given that we have understood broadly what is clustering, what are the important criteria? First of all, it should be able to deal with the different types of attribute. As I said, Boolean, integer, and so on. Okay, it should be able to handle dynamic data, not only static data but dynamic data. Example, air temperature. Air temperature is not static. You go out, it will be hot, come inside, it will be cold. So it keeps changing, dynamic data. That is called data stream. So when we see Netflix, it is called data streaming video, right? So video is continuously coming. As soon as there is a problem with the internet, the streaming will stop. Again, streaming will continue. Those data are called dynamic data. It keeps changing. So clustering should also be possible on dynamic data. The clustering algorithm should be able to detect any arbitrary shape, not only square, rectangle, but any shape. I will show you some examples later. And we should have minimal information to define the input. So even without number of classes, I will say, okay, let me think and group all of you into 2, 3, 4. Without any a priori information, I can go ahead with clustering. Okay. And it should be able to deal with noise and outliers. Outlier we will talk about in the next session. And the very important point is it should be interpretable. I should be able to understand what I have done. Okay, and it should be usable. The meaning should be usable. Finally, because big data is currently into picture, we should be able to scale up the clustering algorithm. Not all algorithms are capable of scaling up. So if you say that, let me use this algorithm for grouping all the Netflix videos, it may not work because the algorithms are not designed to be scalable. So if your data is big data, we have to see that the clustering algorithm is scalable. Okay. And applications, as I just said, one of the most common application is data reduction. It will form groups. So now I can get rid of the large data sets. It is used in hypothesis testing. It is used in predicting groups, socioeconomic group, per capita income group, and so on. And also it has application in outlier detection. Any erroneous value it can detect. Why? Because the erroneous value can become an outlier as separate cluster. So you can say, okay, this can be sidelined. Broader applications of clustering are in pattern recognition, data mining, spatial data analysis. For example, I can create thematic maps in Geographic Information System, GIS, by clustering data points. Example, COVID-19 hotspot. One cluster, red color. Red color means everyone is infected. You go slightly away from that region, yellow color. Then green color. Green color means no one is infected. So what did I do? I clustered people based on COVID test. Positive means put it in the red group, negative means put it in the green group. And some people positive, some negative, put it in the yellow or orange group. Okay. It is used in image processing a lot. Sir teaches some courses on image processing, so he may be in a situation to give you some very good examples of how we can use image clustering in image processing later on after the class, maybe during lunchtime. It is used in market research, and it is used in World Wide Web. Example, let's say you want to do a search on legal documents, legal rules. So when you do a Google search on legal rules, legal documents, there will be a separate repository of such documents. So as soon as you type a law, a legal law, and you want to read about that, maybe the search parameter will directly go to that law related repository and it will fetch those results. Whereas if I talk about earth, or if I talk about, let's say, Amazon forest, so these are different topics. So see that all the information on the web may be clustered, grouped, and as soon as you write the keywords, it will try to search those databases using the keywords based on clustering. Okay. And it has applications in many areas: biology, information retrieval, land use in GIS, marketing. Sir is a a leader in land use programs by Karnataka state government. He has done several projects, supervised several projects. So he is one person who is well known in the state on land use classification. So maybe sir would have used definitely clustering algorithm for initial land use studies. And marketing based on groups, based on age, city planning, earthquake studies, climate studies, economic studies. So everywhere you see clustering is applied, even in banking. I will show you some examples later. Okay, so we have basically covered the idea behind clustering, what it is, what are the potential applications, and in what way it is, what are the prerequisites for clustering, what are the preferences for choosing a clustering algorithm, and what are the potential statistical applications along with real world applications in using clustering. Okay, so now we have roughly got good idea about where we can use clustering. We will go to one important aspect and quickly finish this part. You may be thinking, how do you group objects? You said, okay, put all green together, put all red together, put all blue together, but how do you know that these two red should be close, should be in one group? So this is called a criteria. This is called a criteria that is used to check if these two are green, let's put them in one group. If these two are blue, let's put them in one group. So this checking is called similarity. I want to see which objects are similar. Similar, put it in one group. Dissimilar, put it in different group. Okay, but how do you check that? Similarity and dissimilarity. We check similarity and dissimilarity using something called distance. Using something called distance. Okay, so popularly there are 3 distance measures that are used in clustering. Why 3 distance measures? Because we all know that Euclidean distance is the most popular, we have learned from school, but it may not fit all types of data. Okay, therefore to fill up that we have 2 more distance measure, Minkowski distance and Manhattan distance. Okay, so I have given the formula for each, calculating each distance here. So distance is a measure that is normally used to find similarity, blue and blue, green and green, red and red, 2 people of the same age group, and so on. So distance measures are used to find similarity or dissimilarity, whether 2 things are similar, non-similar. So sir is wearing white and sir is also wearing white and sir is also wearing white. So we have 3 people wearing white. But how I know white? But how do I tell computer that please group all 3 in one? I cannot tell this, right? So what I will say, okay, you do calculate the distance between white and white. If it is 0, merge them together. So I have 3 people with white or similar to white. I will compute the distance, any one of the distance measure, and distance is 0, so I will merge them together. Whereas if I compare the shirt with him, he is wearing blue, distance will be large because white is completely contrastive to blue, so he will not be put in the same group. Okay, so distances are used as a criteria to merge. I can use Minkowski distance. Okay, so this is the formula, and here the value of q is important. So when q is the positive integer, it becomes a Minkowski distance. When q is equal to 1, it becomes a Manhattan distance, and when q is equal to 2, it becomes a Euclidean distance. Square root, remember, distance between 2 points, square root of x1 minus y1 the whole square plus x2 minus y2 the whole square, same thing, square root here. So we see how we are comparing distance. Distance more than 0, distance is non-negative. Distance is equal to 0, the distance of an object to itself is 0, so merge it. Symmetric function, the 2 distance between 2 points is same. Okay, so based on the distance measure, we try to group them. You can choose Euclidean distance, Minkowski distance, Manhattan distance. The formula, generic formula is given there, and for your convenience, I have taken one example. So later on, let's say x is equal to 1, 2, y is equal to 3, 5. Substitute in each of the formulae and see the distance measure. For the same data point, x1 and x2, Euclidean distance is 3.61, Manhattan is 5, Minkowski is 3.27. Most algorithms typically use Euclidean distance, but there are possibilities that some algorithms may use Manhattan and Minkowski distance. Some of you may be using R statistical software for your work. Many of us are using, old people, no, old means not that, old means 10 years old, because now Python is more popular. So there is a function called DIST that is used to compute distance metrics between every possible data point. Okay, so this is the main criteria, main insight behind clustering mechanism. Okay, now let us see how to develop a cluster. Are things clear? Any doubts till this point? Now let's see how to develop a cluster. So first thing is, we need to know what is the criteria. Should I group people based on age, gender, color of the t-shirt? That is called feature. I need to select the feature. What should be the basis for my grouping? That is called feature selection. In data science terminology, that is called feature selection. Okay, then I have to select what is the distance measure. Should I go for Euclidean distance, Minkowski distance, Manhattan distance? Okay, then what is my clustering criteria? So I can put some rules saying that cluster everyone, but anybody who is less than 20, just ignore them. Don't bring them into the picture, because we will only consider graduate people who have done graduation. So anyone less than 20, let's not count them. So I will put a condition. So if there is a condition, you can impose that condition. Then choice of clustering algorithm. There are several algorithms. We will talk about 2 of them. And you see why is the choice important. Remember the Facebook example? Facebook has used density-based clustering. Why? Because they have to group 1.1 billion people, which 1.1 billion means 1.1 billion data points. So simple algorithms will fail. So they have selected DB-scan as one of the algorithms. So the application will decide which algorithm is suitable. Then whether my results are valid, how good, how reliable, and then can I interpret those results? Can I make sense of those results? So these are the basic steps from feature selection to interpretation. Okay. Now if I say that there are two clusters, I want to know whether they are similar or not. So similarity between two clusters, let's say cluster on the left hand side, cluster on the right hand side. Two clusters. I want to see whether these clusters are similar or not. So how do I know that? I can check it using minimum linkage, maximum linkage, group average, distance between centroids, and other methods. See, don't read anything, just see the picture. Minimum distance. So I will take the distance between the closest data point and see if the two clusters are same or not. I am trying to define inter-cluster similarity, whether the two clusters are similar or not, or whether the data points within a cluster are similar or not. So ideally 1, 2, 3, 4 data points should be similar because it's kept in one cluster. So I am trying to see that. So usually a proximity matrix is maintained to see the distance of every point to every other point. But graphically I can use either minimum distance as a criteria to see if clusters are similar, or maximum distance. Take distance between the farthest point and see if the clusters can be merged or cannot be merged. Or group average between cluster 1, cluster 2, or distance between centroid of each cluster. Okay, or there are other methods that we can use to see if clusters are similar or not. Okay, so if they are similar, what should we do? We can merge them. So white of white can be merged unless there is a reason to separate all different variations in white. Gray, for example, right? Gray has several shades: dark gray, light gray. Even our Facebook CEO, he's popular in wearing gray t-shirts. But I don't know if he has several t-shirts of the gray shade or same kind of color. But see that all belong to gray, right? So if I want to differentiate every gray variation, then it's another matter. We can make several clusters, or else we can put all gray into one, all white into one with some variations of white, bright, more bright white, and so on. So this method that I showed you just now, from minimum, maximum, grouping, average, distance between centroid, helps you to decide whether should I merge clusters or leave them separate. Okay, everyone clear till this point? Any doubts till this point? Huh. Linkage. Yes, yes. Which one? Huh. So we will quickly go back. So I am using here different 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 criterias to decide the similarity between two clusters, one on the left, one on the right. So see the word similarity question mark. So I am asking whether cluster 1 and cluster 2 are similar or dissimilar, right? So to decide that, I am using one of these 4 criteria: minimum single linkage, maximum complete linkage. So in minimum single linkage, what I am doing is taking the 2 nearest point from cluster 1, cluster 2 and see if they are similar or not. If they are similar, then we can go ahead and merge them. If they are not similar, means our clustering is good. Or we can use a maximum linkage. So take the farthest point and see if they are similar or not similar. So I have just touched upon 4 different ways to see or to compare 2 clusters and whether those clusters are similar or they are dissimilar. Should we merge them or should we keep them apart? This is the problem here, because we don't have any prior information. It's unsupervised. So we are asking questions and we are trying to resolve it, because there is no training involved. So you have just given me one Excel of data and asking me to group everyone. So I'm thinking how to group. Should I group based on names, A to E in one group, G to, or should I group based on the marks? Should I group based on the age? So there is no prior information. So therefore I am trying to see what are the best possible ways to group and see or check if the groups are similar, not similar. Not similar means my grouping is perfect. Similar means I have done some more segregation, I should merge it, or else it will not make much sense. Like several shades of grey. There is no sense keeping 5 shades of grey as 5 clusters. So let's merge it and make it one cluster. If there is a requirement in future that no, every shade must be separated, then I will go ahead with more clusters, or else I will find a similarity and merge them. So these are the criteria to decide if there is similarity or not. Similarity or not. So these are the 4 ways to check that. Okay. Should we break? Start. 250.
Thank you, sir. And we can have a quick lunch break. Please assemble
So
back at
please
2:15.
2:15, because we have to cover a little bit more. So otherwise Shruti will come, then
Hmm.
she will.
Please be at 2:15.